Today's lesson is on the sums of infinite series. Now, we have studied arithmetic and geometric series and have formulas for the sum of those. But now our objective will be to find the sum of an infinite series, which means a series that goes on forever. So our definition there is one that goes on forever. For example, 3 plus 5 plus 7 plus 9 plus and so on, which would mean, again, this goes on forever. And so it would be logical that there'd be no way you could add up these numbers, because the next number is getting larger and larger, and you keep adding it on and on. The same with 5 plus 10 plus 20 plus 40, which is a geometric series. There'd be no way you could continue to add those up. So it would be, and it is impossible to find the sum of these infinite series because they keep getting bigger and bigger. But how about the series 40 plus 20 plus 10 plus 5? This is a geometric series. Its first term is 40, and its ratio is 1/2 or 0.5. So this would be like standing away from a wall that's 40 feet away, and if you keep going half the distance each time you walk, so you go, or actually 80 feet apart, you'd go 40 feet the first time, and then 20, and then 10, and then 5, then 2.5, then 1.25. You would never get there. So basically, you'd get really, really close, but never get there because you're only going half the distance. So really, they would add up to be 80. So we can say that the sum of this series, and the formula we'll learn on the next slide, is you'll take your first term and divide by 1 minus 0.5. 40 divided by 0.5 is 80, which should be the sum of this series. We could do this because the ratio is less than 1. So the formula to find the sum of an infinite series, you can only find the sum of an infinite series if the series is geometric and its absolute value of its ratio is less than 1. Now that's going to mean the same as that the ratio's got to be between -1 and 1, which means they're getting smaller. If so, the formula for the sum of an infinite geometric series with absolute value of r less than 1 is first term, a sub 1, over 1 minus r. You might see it written like this, using t. You might see it written like this, using g for g sub 1, but it's the first term divided by 1 minus r. Now, you can never find the sum of an arithmetic series if the numbers are decreasing. So these numbers are getting smaller, but there's still no way to add these all up because your next term would be -7, then -10, then -13. It would just keep becoming a bigger and bigger negative number. So examples, finding the sum of the following if it exists. So this first series you can see is arithmetic. It has a difference of +2. So in this case, there would be no sum. There's no way to add those up. This next one is geometric. It has a ratio of 2. Once again, there'd be no way to find the sum of this infinite series. Just as a review, some of you struggled with using the sum formulas before, but in this first arithmetic series, if I would ask you to find the sum of the first 20 terms of this one, it'd be n over 2, so 20 over 2, first term plus your last term. So we'd have to find the 20th term, and our formula would be 2n plus 3, d times n plus the 0 term. Putting 20 in there, we get 43. So it'd be 10 times 48, which would be 480. But if it kept going infinitely, obviously you would not be able to find the sum. For this one, it's geometric. Just a quick review. If we want to find the sum of the first, let's say, 8 terms of this one, remember it is first term times 1 minus r to the nth power over 1 minus r. The bottom is negative 1. And to do this, a lot of you struggle doing this on your calculator. You would take 1 minus 2 to the 8th power. You're going to multiply that by 3, and you're going to divide that by negative 1, which comes out to be 765. This next one, 27 plus 9 plus 3 plus 1, and so on, has a first term of 27. It is geometric. Its ratio would be 1/3. So this, we can find the sum of it because it's geometric. Its ratio is between negative 1 and 1. The formula is first term over 1 minus the r value. So it's 27 divided by 2/3, which comes out to be a total of 40.5. More examples here. We've got a geometric series. First term is 100 and our ratio is a half. So we would take 100 over 1 minus 0.5. 100 divided by 0.5 is 200. This next one is geometric. It has a first term of 8. Its ratio is a negative 1/2. If the signs are alternating, make sure your ratio is negative. So now we'd have 8 divided by 1 minus a negative 1/2. Adding the opposite, so it's 8 divided by 1.5. Which comes out to be 5.3 repeating. And that'd be the sum. This next one looks kind of difficult, but remember to find the ratio of any geometric series, just divide two consecutive terms. So I'm going to take 14.4, divide by 24, that gives me 0.6. I'm going to take 8.64 and divide by 14.4, and that's 0.6. So my ratio here is 0.6, and it is geometric. First term is 24, 1 minus 0.6 on the bottom. 24 divided by 0.4. This would be a sum of 60. Find the sum of that infinite series. I'm going to stop this video now, and then I'm going to be back with you in another video that talks about sigma notation that you'll see on your IXL assignments for today.